Resolve 1 minus x. Resolve 1 minus x all over 1 minus x over x squared minus 3x plus 2 times x squared plus 4 into partial fractions. Resolve 1 minus x over x squared minus 3x plus 2 times x squared plus 4 into partial fractions. The first thing to do is to check if the fraction is a proper or an improper fraction. If we expand the denominator, we'll see that its degree is going to be 4. The result will be a polynomial of degree 4, and the numerator is a polynomial of degree 1. So that means it's a proper fraction because the degree of the denominator is greater than the degree of the numerator. Now let's look at the factors at the denominator. This factor is a quadratic factor. This is also a quadratic factor. Whenever you have a factor that is not a linear factor, you factorize it. But if it's not factorizable, you leave it as it is. Now let's check this. X squared minus 3x plus 2. If we factorize that, we have x squared minus 3x plus 2. Let's try to factorize that. That will be 2 times x squared. That's plus 2x squared. What do we add together to get minus 3x and multiply to get 2x squared? What would that be? That's minus x minus 2x. Minus x minus 2x is minus 3x. And minus x times minus 2x is plus 2x squared. So instead of writing minus 3x, I'm going to write minus x minus 2x. So that means x squared, that simply means x squared minus 3x plus 2 is the same as x squared minus x minus 2x plus 2, which means x into bracket x minus 1 minus 2 into bracket x minus 1. And that's the same as x minus 2 times x minus 1. So that means x squared minus 3x plus 2 is the same as x minus 2 times x minus 1. So that's what I'm going to write. This is the same as 1 minus x all over x minus 2 times x minus 1. X squared minus 4, x squared plus 4, x squared plus 4 cannot be factorized. It's not factorizable. It's different from x squared minus 4. X squared minus 4 is x squared minus 2 squared, which is the difference of 2 squares, and that will be x plus 2 times x minus 2. X squared minus 4 is factorizable, but x squared plus 4 is not factorizable. So I'll leave it as it is, x squared plus 4. Now, how do we now resolve that into partial fractions? How do we resolve that into partial fractions? How do we now resolve 1 minus x over x minus 2 times x minus 1 times x squared plus 4 into partial fractions? So now we know that to resolve into partial fractions, we must check the factors at the denominator. This is a linear factor, so the numerator of its partial fraction will be a constant, which is the same as a polynomial of degree 0. The degree of a linear factor is 1, so the numerator of its partial fraction should be a polynomial of degree 0, and that's a constant. Let's call it a. So that's a over x minus 2. It's also a linear factor. Its numerator will also be a constant, plus b over x minus 1 plus. This is a polynomial of degree 2. That's a quadratic factor. So the numerator of its partial fraction is going to be, the numerator of its partial fraction is a linear expression. So we write the general form of a linear expression. That's cx plus d. I'm using cx plus d because I already used a and b. So you see that the numerator of the partial fractions the numerators are 1. The degree of the numerator of each of the partial fractions is 1 less than the degree of the denominator. That's a check. This is of degree 1, this is of degree 0. This is of degree 1, this is of degree 0, this is of degree 2, and this is of degree 1. Now let's find the values of a, b, c, and d. This will be equal to the LCM. The LCM is, let's write all the factors, x minus 2, x minus 1 times x squared plus 4. That's the LCM of the denominators. So when you divide this LCM by x minus 2, we have a into bracket x minus 1 times x squared plus 4 plus b into bracket. When you divide this LCM by x minus 1, you have b into bracket x minus 2 times x squared plus 4 plus, I need some more space, plus, when you divide this LCM by x squared plus 4, you have cx plus d into bracket x minus 2 times x minus 1, cx plus d into bracket x minus 2 times x minus 1. I want to make sure that there's enough space to contain it. Yes, cx plus d into bracket x minus 2 times x minus 1. And now this is equal to this. We can see that the denominators are the same. That means the numerators are also equivalent. So I can say therefore that 1 minus x is the same as a into bracket x minus 1 times x squared plus 4 plus b times x minus 2 times x squared plus 4 plus cx plus d times x minus 2 times x minus 1. Now let's call this equation 1. Putting x equals 1 in equation 1, we're using the cover-up method to find the constants. Putting x equals 1, 1 minus 1 will be equal to a into bracket 1 minus 1 into bracket 1 squared plus 4 plus b into bracket 1 minus 2 into bracket 1 squared plus 4 plus c into bracket 1, cx will be c times 1 plus d times x minus 2. That means 1 minus 2 times x minus 1, which means 1 minus 1. We'll see that 1 minus 1 is 0. That means the whole of this will be 0. 1 minus 1 is 0 here, which means the whole of this will also be 0. So we'll be left with, on the left hand side, 1 minus 1 is 0. That means 0 equals, this is the only thing that will be left on the right hand side. B into bracket minus 1. 1 square is 1 plus 4, that's 5. Minus 1 times 5. And that simply means 0 equals minus 5b, which therefore means b equals 0. If you divide through by minus 5, you get b equals 0. Now, let's putting x equals 2 in 1. If I put x equals 2 in equation 1, what do I have? 1 minus 2 will be equal to a into bracket 2 minus 1, a into bracket 2 minus 1 into bracket x squared plus 4, that means 2 squared plus 4 plus b into bracket 2 minus 2 plus b into bracket 2 minus 2 times x squared, that's 2 squared plus 4 plus cx means c times 2, cx plus d times x minus 2 times x minus 1, which means 2 minus 2 times 2 minus 1. So here 2 minus 2 is 0, that means the whole of this will be 0. 2 minus 2 is 0, that means the whole of this will be 0. And we'll be left with minus 1 equals 2 minus 1 is 1. 2 squared is 4 plus 4, 4 plus 4, 8. So that's a into bracket 1. A times 1 times 8, and that means minus 1 equals 8a, which simply means a equals minus 1 over 8. Now we have found a and b. What else can we do? At times you use both the cover-up method and the comparing coefficients method to solve, to get all of the constants. Now let's see, what other value can we put? Okay, let me put x equals 0. If I put x equals 0, it will make the equation simpler. Putting x equals 0 in 1. Putting x equals 0 in 1. I can see that if I put x equals 0, that will cancel out c, because c times 0 will be 0. And I'll be left with a, b, and d. Since I already know a and b, then I'll be able to find d from that. Putting x equals 0 in 1. 1 minus 0. Don't forget, this is equation 1. This is equation 1. The left hand side is 1 minus x. That means 1 minus 0 equals a into bracket x minus 1, which means 0 minus 1, into bracket x squared plus 4 times 0 squared plus 4 plus b times x minus 2 times x squared plus 4. That's b times 0 minus 2 times 0 squared plus 4 plus cx plus d plus cx plus d, that means c times 0 plus d times x minus 2, 0 minus 2 times x minus 1, which is 0 minus 1. And this simply means 1 equals a into bracket minus 1 times 4 plus b times minus 2 times 4. C times 0 is 0, that's plus d into bracket minus 2 times minus 1. And that simply means 1 equals minus 4a minus 8b plus 2d. Now we already know the values of a and b, so we can substitute them here to get d. So that means 1 equals minus 4 into bracket, what is a? Minus 1 over 8. Minus 4 into bracket minus 1 over 8 into bracket minus 1 over 8 minus 8 into bracket 0. B is 0. Let's check that again. B is 0. So that's minus 8 times 0 plus 2d. And that simply means minus 8 times 0 is 0, and we are left with 1 equals 4 here 1, 4 here 2. And that will be minus times minus 1, that's plus 1, that's plus 1 over 2 plus 2d. And that simply means 2d equals, or I can write it this way, 1 minus 1 over 2 equals 2d, which means 1 over 2. 1 minus half is half, that means 1 over 2 equals 2d. And that therefore means d equals, if we divide through by 2, d will be equal to 1 over 2 divided by 2 is going to be 1 over 4. D is equal to 1 over 4. Now the only term we're left with is, the only constant we're left with is is C. So how do we find C? Let's go back to the equation. This is the equation. How do we find C from this equation? Let's see. Okay, let me just put a value, substitute a value for x that will not cancel out C. What value can I substitute for x that won't cancel out C? Okay, let me put x equals, I put x equals 2, I put x equals 1. Okay, let me put x equals minus 1. Yes, putting x equals minus 1. Putting x equals minus 1 in 1. That simply means, let's see the equation 1. Maybe we should even bring it down so that we can see what we're copying. This is equation 1. Let's bring it down. Equation 1. Let's put x equals minus 1 in equation 1. So let's have it here. Putting x equals minus 1. That simply means 1 minus 1 is equal to a into bracket minus 1 times minus 1 squared plus 4 minus 1 squared plus 4 times minus 1 minus 2. No? Am I writing? A into bracket x minus 1 times x squared plus 4. That's it. A into bracket minus 1 minus 1. A into bracket x minus 1 times x squared plus 4. That's this. Now the next one is plus b into bracket x minus 2. That will be minus 1 minus 2 times x squared plus 4. That's minus 1 squared plus 4. And the next one is plus cx plus d plus cx, that's c times minus 1 plus d times x minus 2, that's minus 1 minus 2 times x minus 1, which is minus 1 minus 1. So we can take this out. Now, so that's it. And now we simplify for that. That means 1 plus 1 equals a into bracket minus 2. The square of minus 1 is 1 plus 4, that's 5. Minus 2 times 5 plus b into bracket minus 2 minus 1 minus 2 is minus 3. B into bracket minus 3 times the square of minus 1 is 1 plus 4, that's 5. And then plus, what do we have here? Let's write that here. Plus c times minus 1 is minus c. That's minus c plus d times minus 3, minus 1 minus 2 times minus 1 minus 1. That's minus 2. And that simply means 2 equals minus 2 times 5 is minus 10 times a. That's minus 10a. That's minus 10a. Minus 3 times 5, that's minus 15 times b, that's minus 15b. Minus 3 times minus 2, that's plus 6. Plus 6 into bracket, minus c plus d. And that's the same as minus 6c plus 6d. Let me write that on the next line. That simply means 2 is equal to minus 10a minus 15b minus 6c plus 6d. Now we already know the values of a, b, and d. So we put them in this equation to get c. So that simply means 2 equals minus 10. What is a? A is minus 1 over 8. A is minus 1 over 8. So that's minus 10 into bracket minus 1 over 8 minus 15. B is 0. You know that. Minus 15 times B. That means minus 15 times 0 minus 6c plus 6d. What is d? Let's check that. What's the d? Is 1 over 4. So that's plus 6 times 1 over 4. times 1 over 4. And that simply means 2 is equal to 2 here, 5, 2 here, 4. That means minus 5 times minus 1, which is plus 5 over 4. This will be 0, minus 6c, 2 here, 3, 2 here, 2, plus 3 over 2, which simply means let's take minus 6c to the left-hand side. And it becomes plus 6c, and I'm taking 2 to the right-hand side. So plus 6c equals 5 over 4 plus 3 over 2. When 2 goes to the right-hand side, it becomes minus 2. And that simply means, what do we do here? Find the LCM. The LCM is 4. That will be 5 plus 2 in 4. 4 divided by 2 is 2. 2 times 3, 6 minus, this is 2 over 1. 4 divided by 1 is 4. 4 times 2, 8. So that simply means 6c equals 5 plus 6, 11. 11 minus 8, 3 over 4. And now we divide through by 6. That means c equals 3 over 4 divided by 6 means 3 over 4 times 1 over 6. And that simply means c equals 3 here 1, 3 here 2. And that's 1 over 8. Now we have all of the constants. And we can now say, therefore, 1 minus x over x squared minus 3x plus 2 times x squared plus 4, which is equal to, don't forget that we split this into 2 factors. Yes, we actually split that into 2 factors to get a over x minus 2 plus b over x minus 1 plus cx plus d. I'm writing it so that we see what we resolved it into, which is therefore equal to a is, what is a? A is minus 1 over 8. Minus 1 over 8. So that becomes that minus 1 over 8 into bracket x minus 2 plus b, which is 0 over x minus 1. B is 0, so that's 0 over x minus 1 plus cx plus d. C is 1 over 8 and d is, what's d? D is 1 over 4 plus cx plus d. That means, let me write this way, plus 1 over 8x plus d, which is 1 over 4, and the whole of that all over x squared plus 4, which simply means minus 1 over 8 minus 1 over 8 into bracket x minus 2. Of course, this is 0 plus. Now let's merge these two fractions. 1 over 8x plus 1 over 4. 1 over 8x plus 1 over 4. The LCM is 8. 8 divided by 8 is 1 times 1x. That's x plus 8 divided by 4 is 2. 2 times 1, 2. So that's x plus 2 over 8. So that simply means x plus 2 over 8. This numerator is the same as x plus 2 over 8. Now, if we divide that by x squared plus 4, it's going to be the same as x plus 2 over 8 divided by x squared plus 4 over 1, which simply means x plus 2 over 8 times 1 over x squared plus 4. And this is what is going to become x plus 2 over 8 into bracket x squared plus 4. So that's what I'm going to write here. Instead of this, that's what I'm going to write. So we have that as x plus 2 over 8 into bracket x squared plus 4. And that is it, very, very simply. That's what we get when we resolve this into partial fractions.